Alright, so the last thing we're going to do is the hypergeometrical. The book doesn't call it that anymore. And it's where you select from several groups and without replacement, and order doesn't matter. So here's a type of example we might do. Suppose we have 50 widgets, fictional thing, and we know 5 of these widgets are defective. What is the probability if we select 4 widgets, 1 is defective? So what we need to do, like a typical probability problem, probably is the number of things in the event divided by the number of things in the sample space. Okay, so let's look at each one of these separately. The number of things in the event, well, that would be all the things that are, all the different ways that we can select the one defective one times all the ones that we can, or the rest of them that we select that are not defective. So if there's 5 defective ones, widgets, there has to be 45 non-defective, right? And if we select one of those, there has to be 3 that we're not selecting. Okay, so this is of the 4 that we're selecting. So of the 5 things, there's 5 things, we select 1 of them. Times, of the 45 things, we select 3 of them. That's our number of things in our event. The number of things in our sample space would be to ignore that classification and just say there's 50 things and we're selecting 4 of them, since order doesn't matter. Alright, so now the probability then, of course, would be just to plug these in. 5 choose 1 times 45 choose 3, all over 50 choose 4. Notice that these 2 add up to that one, and of course the other 3 add up to the other. The 5 plus 45 is 50, 1 plus 3 is 4. Alright, so now you can just plug this in your calculator. And we would get 5 choose 1, which is actually just 5. Anytime you choose one of it, it's just the 5 things. And 45 choose 3 divided by 50 choose 4, and we would get 0.0381. 3081 for a probability. So when you do these, you break it down into groups. Okay, and that's the hypergeometry.